Hi everyone, this is KC5 of Integrated 3 on Rational Functions. So we are going to start with section 3.2, day 1, which is on transformations. Now, recall that we've already done this before. Okay, we had functions, cubic and quadratic functions, or functions that are x squared or x to the third, and then we transform them into translating into different directions. Okay, so let's recall a transformation from f of x is equal to x to the third that we have here to g of x is equal to x plus 5 to the third minus 6. Okay, so you can see that we added a 5 inside the parentheses and we added a negative 6 outside of the parentheses. Now those two things are going to transform that graph differently. Okay, so if you have a number inside the parentheses, your graph is going to move left or right. And it's going to be the opposite. Okay, what I mean by that is if it is positive 5, then it's going to move to the left because positive numbers usually go to the right, and the opposite of that would be the left. Now, numbers outside of parentheses are going to move up or down, and since it is outside of parentheses, these are not the opposite. So, for example, this function right here will move left 5 units and down 6 units, which would be my final answer. Okay, so for this unit, we are going to focus on rational functions, and if you recall, rational functions is a rational number is a number that can be written as a fraction. That's the easiest way to explain it. So we are going to be dealing with functions that have fractions. Okay, and we're going to focus on the rational function f of x is equal to 1 over x and how that graph looks like. Okay, so f of x is equal to 1 over x is our parent function. Okay, if you remember, our parent function is x squared, x to the third. It's just your variable with something happening to it. You're not adding any other numbers or subtracting any other numbers like we did above. Okay, so the parent function, f of x is equal to 1 over x looks like this on a graph. So you have a graph, and you have two lines, one going up and down, and then the other one in the other direction where they're across from each other. Okay, so your graphs for this chapter or this unit are going to look like this. Now, your general formula for transformations is f of x is equal to a over x minus x, or x minus h, excuse me, plus k. Well, now, for this unit in particular, we're going to focus on when a is equal to 1. And we need to figure out what that changes, okay? So a actually stretches or shrinks your graph. And again, we're only going to focus on when a is equal to 1, so we don't have to worry about that too much. H is like your number inside parentheses that we did above. I want you to think of h and x being together in parentheses because they are both under that function, that division sign, so they are together. So this is going to move left or right, just like above, and again, it is going to be the opposite. That is the one with the x. Excuse me. And then last but not least, my k. K is going to move either up or down. It is not the opposite. Okay, so all we're going to do here is going to describe the transformations that happen in these following examples. So describe the transformation from 1 over x to 1 over x minus 3 plus 4. Okay, so you see that you have a negative 3 here and a positive 4 here. If I look at my general function for transformations above, the one on the bottom, that negative 3, will move it left or right. Now, because it is a negative, And the opposite of that would be to go to the right. So it moves right 3 units. And this number right here will go 4 units up since it's positive, which is my final answer. Okay, I want you to go ahead and pause this video and try example number 2 before I go ahead and write the answer on here. So I have a positive 4 with the x, so that is going to be the opposite. So it is going to be left 4. And the negative 5 is not the opposite, so down 5. Which is my final answer. Now you are also able to sketch graphs given functions that are transformed. Okay, and to do that, you're gonna do what we did in example 1 and 2. You need to know the answers to that, and that's gonna help you sketch the graph. Okay, so for example, if I want to sketch f of x is equal to 1 over x plus 2 minus 5, again, I'm gonna look at my plus 2 and that negative 5 that they added on there. So that means it is going to move left 2 and down 5. Now, when you are graphing, you want to remember that you are going to start at 0, 0, okay? And that's at your origin right here. So I have a graph. I'm going to start right there, and I'm going to transform. So let me write some. Draw some lines on there. So I'm going to go left 2 from my origin. So 1, 2, and down 5. Okay, so right here, at left 2, I'm going to draw an imaginary line. That is called an asymptote, and we are going to go over that later on. So I go left 2 and down 5 here. So it has to cross that point, that left 2 and down 5. Now this will become, that dotted line will become my new starting point. So when I graph this, again, it's going to look like your parent function up here. Okay, so it's going to look like this. The only difference is that it's not going to cross the, like here it doesn't cross the x and y axis. Well, now it's not going to cross those imaginary lines that we drew in here. So it's not going to cross this line. It's not going to cross this one. And that's it. Okay, so if you want to try the next one on your own, go ahead, pause the video, and I will work this out now. So on this one, I have a negative 3, so that means it goes right 3. And a positive 4, which means it goes up 4. Okay, so I'm going to go ahead and draw my lines here. Okay, so right 3 and up 4. So it's going to have to pass, my imaginary lines are going to have to pass this point. So one here. And this goes on forever and ever. And then one here. Okay, so those are my asymptotes. Those are the lines that my graph will not cross. Okay, so again, the graph is going to look similar. It's those curved lines that are across from each other. But this is going to be where it doesn't cross. Those lines, those imaginary lines that I drew, are going to be where that graph does not cross anymore. And that's it.